Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 8 from the October 2022 International A-Level Edexcel Pure Mathematics P3 paper. This question here is about trig identities and equations, and also this is specifically about what we call the addition formulae, or the compound angle formula, as they're called. So first of all, typical question: express 8 sine x minus 15 cosine x in the form r sine x minus alpha. So they want these two separate trig functions expressed as one function with this compound angle. So we got to take 8 sine x minus 15 times cosine of x, and we got to express it so that it's identical to r sine x minus alpha, where r is positive and alpha is a acute angle between 0 and pi/2 or 90 degrees. Give the exact value of r and give the value of alpha in radians to 4 significant figures. So we got to take note of that. Normally we write things to 3SF unless otherwise stated. Here we have otherwise stated. All right, so now what we're going to do now is we're going to look at the formula sheet, which eventually you won't have to once you have got used to this, but the formula sheet will tell us how this splits up, right? So one of the things that a lot of students in the beginning, they have a bit of an issue with, they think, for example, the sine of A plus B is equal to the sine of A plus the sine of B, for example. And that's completely wrong, okay? It's not like x times a plus b, which would give you xa plus xb. That's correct, because x in itself is something complete by itself. It's a term by itself. But sine without an angle, this doesn't have any meaning in terms of mathematics, right? It has to have an angle associated with it, and the angle associated with it is the whole of this a plus b. So when you expand something like this, it doesn't expand in this way at all. So that's one misconception, hopefully, that you can, get out of your minds. Now, in order to expand it, we're going to use the formulae that we're given in the formula book. There is a proof for it. We don't need to go into that. We can just look at the formula book, and we can see that we're concerned with this. So I'm going to take this. I'm going to take this, and we'll look at it in context of the question that we have. So I'll just paste this over here, make it a bit smaller. And we'll look at this in context of the question that we have here. So basically, what we can see from this, I'll just put it up there for now, is that we want to split this up, okay? Sine A, this is like your A, and this is like your B. So your A is the X, and the B is the alpha. And we're going to split it up so that it looks like this. So we can see what it says: sine A minus B will be sine A cosine B minus cosine A sine B. So this will give you, there's an R multiplying them, both those terms as well. So you have R sine A. Now our A is X, cosine B, so cosine alpha. Now there's a minus. If there's a minus here, there's also a minus there. So there's a minus here, so there's a minus between them. And remember that R is multiplying both these terms. So R times, then you have cosine of A, which our A is X, and sine of B, and our B is alpha. So cosine X, sine alpha. So that's how this will split up. So you have 8 sine X minus 15 cosine alpha, cosine X, is equal to this. Okay, so now we want to express this in that form. So what I'm going to do now is I'm going to try to find out what R is and what alpha is by comparing these two. Okay, so that's how we deal with it. We compare these two. So I'm going to compare the coefficients of sine x first. So on the left-hand side, the coefficient of sine x, if you look at sine x, what's multiplying the sine x? Okay, so here's the sine x. On this side, what's multiplying it is 8. Here's the sine x on the right-hand side of the equation, or the identity, and what's multiplying it is r cosine alpha. So what we can say is this 8 must be equivalent to, must be exactly the same as r cosine alpha, because these two things must be the same. And if I compare the coefficients of cosine x on both sides, okay, if I compare the coefficients of cosine x on both sides, I have on this side that 15 here, and here I have r sine alpha. What am I doing? Sorry, let me just highlight the cosine x and the cosine x. Okay, so on this side I have minus 15, and this side I have minus sine alpha, right? So we don't have to worry about the minus because they will cancel each other out anyway. So I could write 15 is equal to r sine alpha. Now with these two together, I can now calculate alpha and r quite easily. There's two ways of doing this. One of the ways is by drawing a right angle triangle. Okay, I'll just do it by I'll do it like this. So I'm going to draw a right angle triangle, just a random right angle triangle. Okay, and we know that if we call this alpha and this is a right angle, okay, then the sine of alpha, okay, is going to be 15 over r, and the cosine of alpha is going to be 8 over. So I mean, I don't have to do this. I'm just going to make it a bit more realistic. Okay, I'll just make it a bit more realistic. Get rid of this. Sorry about that. Let's sort this out. Okay, so the sine of alpha would be the opposite of alpha here, which would be 15 over r. And the cosine of alpha would be the adjacent over r. So you can see from this, you have cosine alpha equals 8 over r. And we have from this sine of alpha is equal to 15 over r. Right? So from this, we can calculate r by Pythagoras' theorem. We can say r squared is equal to 15 squared plus 8 squared. So r is equal to the square root of 15 squared plus 8 squared. So we can work out what r is. So we can say the square root of 15 squared plus 8 squared. Okay, and that gives us 17 exactly. All right, so it's exactly 17. And we can also work out what alpha is by using, for example, tangent. We can say the tangent of alpha is opposite, which is 15, over adjacent, which is 8. So alpha is the inverse tan of 15 over 8. Make sure that we are in radian mode, radians. Okay, so I have to make sure the calculator here is in radian mode. Now the calculator is in radian mode. That's fine. So I'll say inverse tan of 15 over 8. That gives us 1.08083. So that gives me alpha equals 1.08083, 1.08083 continues on. Now we want this to 4 significant figures. So that's 1, 2, 3, 4. We stop over there. So that's going to be 1.081. Okay, that's 4 significant figures. So it says express this in this form. So we don't just write down the value of r and alpha. We express it in the form. So we can say 8 of sine alpha, 8 sine of alpha minus 15 cosine of alpha is equal to 17 times the sine, okay, of x minus alpha. So x minus 1.081. Okay, so that's our answer. That's what we had to show. 8 sine x minus 50, sorry. Should be x. What do I write alpha? 8 sine x minus 15 cosine x, not alpha. So 8 sine x minus 15 cosine x is equal to 17 sine x minus 1.081. That is our answer. Okay, here r is an exact formula. It's exact anyway. And alpha is to 4 significant figures. And that concludes question 8a. All right, now for 8b. It says it says f of x equals 15 over 41 plus 16 sine x minus 30 cosine x, where x is greater than 0. Find first the minimum value of f of x, the minimum value of f of x. Now, in this kind of question here, we have to be very careful. Okay, first of all, these questions, part A and part B, are normally very much linked. Whenever you have to rewrite this in a particular form like that, it's always linked to part B. All right, even though it doesn't say hence or even though it doesn't say using your answer to part A, you should realize that we should always keep in mind what we just did. So if I compare 8 sine x minus 15 cosine x, and this, you can see there's some sort of link here. Okay, if I look at this, this is like 41 plus 2 times what we have here. So it's 2 times 8 sine x minus 15 cosine x. All right, so this is the same as this, which can be replaced by all of that. So what I can do is I can say from here that f of x can be rewritten in a way that will make life a bit easier for me to work out its minimum value and to work out the smallest value of x which this occurs. If I write it in this form, you will understand, or if I write it in this form, you'll understand how it makes life easier. So I can say this is like 15 over 41 plus 2 times 8 sine x minus 15 cosine x. And I can rewrite this, I can take this and replace it with 17 sine x minus 1.081 radians. So I can say this is equal to 15 over 41 plus 2 times, and I have 17 times the sine of x minus 1.081. 1.081. Okay, so that will give us 34 here. So this is like 15 over 41 plus 34 times the sine of x minus 1.081. Now, written in this form, I can very easily find out the minimum value of f of x and also the smallest value of x at which this occurs. Okay, so let me just move this out of the way. So now, it makes life a lot easier for us to find the maximum and minimum values of these. Now, with fractions, when your denominator is very small, the numerator is big. For example, if I have 15 over, for example, 1, I get 15. If I increase the denominator, okay, then the value gets smaller. 15 over 2 is 7.5. 15 over 3 is 5. 15 over 5 is 3. Okay, as the denominator gets bigger, the value of the whole fraction gets smaller. So the minimum value of f of x, so the minimum for f of x is when 41 plus 34 times the sine of x minus 1.081 is maximum. When you get the biggest possible denominator, you get the smallest value of the whole fraction. 15 is fixed. This can change because this changes depending on what x is. So when this whole denominator is as big as possible, the fraction becomes as small as possible. And we can say the maximum value of the maximum for 41 plus 34 times the sine of x minus 1.081, okay, is going to be when the sine of x minus 1.081 is its maximum value. Okay, when is this the maximum value? Well, the maximum value for the sine of any angle, as we know, the sine curve goes like this and like this. The maximum value of the sine of any angle is going to be 1. Okay, so it's the maximum value which is equal to 1. Okay, which is 1 basically. So now we can work out that, you know, the minimum value of f of x is going to, when you have 15 over 41 plus 34 times 1, which is 15 over, that's 75. 15 over 75, well, 15 over 75, what does that give us? Is that 1/5? 15 over 75, that gives us 1/5, that's right. So That's the minimum value of f of x. The minimum value of f of x is equal to 1/5. Okay, I'm going to move this to the other page because I don't have space on here. I'll just put that over there. Deal with that in a minute. Okay. Then that's part 1 of B. So we finished part 1 of B. Okay. Now for part 2 of B, it's very much linked to this. It says, find the smallest value of x at which this minimum value occurs. Okay, so we got to find the smallest value of x for which sine of x minus 1.081 is equal to 1. The smallest value of x for which this is true. That's when the minimum value of f of x occurs, when this is equal to 1. Okay, so we got to find the smallest value of x for which this is true. So what we can do is we can say x minus 1.081 is equal to the inverse sine of 1. Okay, now the inverse sine of 1, okay, is going to be equal to 90 degrees or pi over 2. So let's confirm that. Inverse sine of 1, we're in radian mode, so it's pi over 2. As we know that the sine curve reaches maximum of 1 at pi over 2 the first time. So we can say that x minus 1.081 is equal to pi over 2. So x is equal to pi over 2 plus 1.081. So x is therefore equal to plus 1.081. That gives us, whoops, I forgot the point. That gives us, what's happened here? Our answer, well, let's see, pi over 2. I think I had a different answer there. So pi over 2, okay, plus 1.081. That's better. That gives us 2.6517, 2.6517. Now, they didn't tell us how to write the answer, so we'll write it to 3SF in the end because that's our general. So the value is 2.65 radians. That is the value of x, okay, the smallest value of x at which this minimum occurs. So the answer there is 2.65. Okay, that's the value of x for which this equals 1. When this equals 1, that's when this has its minimum value. Okay, so there's the answer to part B. So the important thing here is for us to understand a fraction has its smallest value when its denominator is as big as possible. Okay, it would have its biggest value when the denominator is small as possible. In that case, this would have to be -1. Okay, and it says state the y coordinate of the minimum points on the curve with the equation y equals 2f of x minus 5, x is greater than 0. So now, we know that for y equals f of x, we just found that the minimum point was 2.65 and 0.2. So now we're concerned with the y coordinate. Okay, we're concerned with the y coordinate, okay, which is this 0.2. So the equation y equals 2 times f of x minus 5, well, this will only affect the y coordinate. This is to do with transformations of graphs. There's a combination of transformations. So what happens here, if it's outside the function, we follow BIDMAS. So first we take the minimum point, the minimum y value, and we multiply it by 2, and then we subtract 5 from it. So you're going to have 2 times 0.2, and you take away 5 from that. Okay, so that's going to give me 0.4 minus 5, which is negative 4.6. So that will be the y coordinate, negative 4.6. The x coordinate will actually stay the same, but they're only asking for the y coordinate, so we don't have to worry about writing that down. They only want the y coordinate. If they said find the coordinates of the minimum point, this will be 2.65 and minus 4.6. Okay, so that is after this transformation, the y-coordinate of the minimum point on the curve. Okay, so all the minimum points will have, so basically the minimum points, all of them will have this y-coordinate, and the first minimum point will be the one which has an x-coordinate 2.65. Okay, so then it says, state the smallest value of x at which a maximum point occurs for the curve. So again, we have the minimum point as the x value for that was 2.65. And the y value for that was 0.2. So we've got now, this is for y equals f of x. That's a minimum point. Now we got this transformation, y equals minus f2x. So what effect does the 2x have? That effect has that affects the x coordinate. So the x coordinate is basically stretched horizontally by a factor of a half, the reciprocal of this number. It's like the opposite. When it's inside the function, the opposite happens. So basically this 2.65 is divided by 2. Okay. All right. Now, but the thing is, they're asking us for the maximum. This is the minimum. But the negative here causes the whole thing to reflect in the x-axis. It's outside the function, so it's going to be a vertical type of transformation. So the whole thing reflects in the x-axis. So if this is the minimum, okay, then the maximum is going to be when it's reflected in the x-axis. Okay, for the new curve, the maximum is going to be when it's reflected in the x-axis. All right. So what's going to happen now is the minimum is now going to become a maximum. This is now going to become a maximum. So this point, the maximum is now going to become, the minimum will turn into maximum because it's reflected in the x-axis. Okay. So we don't have to worry about this coordinate. Okay, but this now is going to be the x coordinate of not the minimum, the maximum. Okay, because it's reflected in the x-axis, so what was the minimum now becomes the maximum. Okay, when it's reflected in the x-axis. So our answer for the x coordinate is basically going to be just 2.65 divided by 2. Okay, so 2.65 divided by 2, which gives us 1.325, 1.33. In fact, what I'll do is I'll take actually the more accurate value that we had before, which was, this was it. So we divide this by 2 just to give us a more accurate 1.33. Yeah, that's fine. So 1.33, I'll write it to 3SF as well. So that's the x coordinate of that's the smallest value of x at which the maximum point occurs. That's the x coordinate of the maximum. Okay, for this this transformation of the original curve. Okay, so what we understand is because there's a minus in front of the whole function, it reflects in the x-axis. So what was a minimum before now is the maximum of the curve. And we also understand that the 2x means that there's been a transformation of a factor of a half in the x direction. So the x coordinate is divided by 2. They only want the x coordinate, so we just write 1.33. Okay, so there's the answer to question part D of 8, and that finalizes this question. It's all about trig identities and the addition formulae, and also transformations of graphs. All those 3 different kind of topics are in here. So if you would like to see other questions from this particular paper, P3 of October 2022, you can find the playlist for that in this region here. You want to find questions which are related to this topic of trig identities and equations. You can find that over here, the playlist for that over here. For transformations of graphs, you'll find that playlist over here. That will be under functions, graphs and functions. I'll put that there as well. And if you would like to watch a video which explains how to use the channel in a more efficient manner, you can watch the video. The link will appear over here. Thank you for watching and see you soon.